Alright, Chapter 5, Introduction, Waveform, Interpretation. Learning objective. I'm pleased for the chapter you will be able to do with the following. Explain with the waveform, interpret with the test, application, identify the different type of the modulation, method of measuring device, modulation, explain the various with the spectrum, analyze the explain with the various with the time domain, reflectometers, identify various steps that have been performed with the sweep, the frequency technique, introduction, waveform, the measurement, the performance of the oscillator with the time domain, with the reflective the meter, with the spectrum analyzer, and able to view the signal, produce the equipment circuit under the test, over the visual display with the no with unless you are able to interpret the signal character of the display with the waveform, the representation various signal, the relay of the time, the graphically, the lot with the unknown waveform of the system, with the coordinate with the amplitude of the unknown signal plotted linearly against with the test analyst with the result of the resonant waveform provided with the view of the available information. The characters of the many electronic and some of the mechanical devices. For example, the waveform signal may be indicative of the presence of the harmonic parasitic oscillation, or the may indicate how closely a device is following the desired cycle of operation is part of the amplifier being shifted with the deteriorated wave distortion. Often occur with the intermediate abnormal operation for the circuit. They often perceive with the circuit breakdown malfunction with the electronic circuit. With the equipment can be used to trade with the waveform inspection specific parts of the circuit that responsible for the distorted signal. One of the base of these facts. Apparently, that there's an important need for the test of the equipment can provide the visual presentation of the waveform is an instant of the currents of the circuit. The distortion is determined the use by the technician engineer that are likely to generate the signal to satisfaction shape of the wave of the process by the amplifier. Distortion the wave with the undesired with the deviation shape of the observed signal with respect to the reference waveform, classifying any of the wave distorted waveform with reference to the electronic circuitry that is involved with the waiting list for the waveform can be validly teamed the distort with the respect to the specific amplifier circuit that may be the normal waveform to be expected with another amplifier circuit. One of the most important steps of the waveform analysis that usually provide with the most difficult with the maintenance personnel the interpretation pattern of the down the test equipment. Chapter will cover some of the basic test method of the practices with waveform interpretation, modulation measurement. The modulation measurement is sometimes required during the time tuning to perceive the adjusting transmit the equipment, the proper amount of the modulation during the maintenance step of the modulated transmitter. The equipment is used to determine the amount of the distortion with the opposite of the modulation level, the index of the modulation level, in multiplexing equipment usually shipped to the factory during the corrective maintenance. Perceive the poor adjustment of the input signal level, the automatic signal level, the regulation. The circuit can provide the correct amount of modulation to deflect the modulation circuit with the transmitter. Can check with the measurement of the quality of the receive the signal at the receiver the correct maintenance. The analyst multiplex of the equipment modulation circuit usually made with a single level measurement. Some radio stations move the optic with the AM and may be adjusted for the correct modulation during the normal tuning perceived with the modulation level over the low of the transmitter not up to the immediate maximum efficiency. On the other hand, the modulation excess of 100% due to this serious distortion. Since neither of these conditions is desirable, amplitude modulation should be made between 60 and 95 when possible. Modulation level and amplitude modulation over the frequency modulation radio transmitter they operate with a very high frequency range. Usually adjust the manufacturer during correct maintenance of the amplifier gain of the modulator can be initially adjusted with the reference of the modulation media provided with the front panel of the equipment. Pulse modulation for the radio beacon signal can be measured with the waveform display presented with the standard oscillator with the amount of usable energy of the pulse waveform is measured by the spectrum analyzed with the induction of the pulse modulation quantity. Attaining 100% of the amplitude modulation of the radio frequency carrier with the signal wave the required modulation power equal to 1/2 of the radio frequency carrier power. Under this condition, the average power of the modulator carrier is equal to 1.5 average unmodulated carrier power. The added power is divided equally between the upper and lower sideband during the peak of the 100% modulation. The amplitude of the carrier is double the blue color. The intense peak of the power of the 4 times instantaneously unmodulated peak of the power is equal to the voltage squared over the of the voice. Modulation is employed with the highest amplitude peak of the amplitude with the modulated with the carrier 100% of the many speech components do not modulate carrier the 100% average power required with the voice modulation left than the required modulation with the same wave. The voice peak they usually may carry at 100% of the modulation creep the average carrier of the output with the 25% of the over normal value. Amplitude modulation measurements. The increase of the power of the output AM transmit with the increase of the antenna with the increase of the can be taken the measure for the degree of the modulation can be expressed with the percentage shown figure 5 on the graph of the figure the relationship existing between carrier power and increase of the power resulting and from the added modulation power of the formula calculating the percentage of the modulation as follows. Percentage of the modulation is equal to 1 time the highest peak of the voltage over the unmodulated carrier time minus the unmodulated carrier over the unmodulated carrier. So the peak increase of the antenna current with the percent of the modulation. Use of the formula based on the assumption of the modulated voltage of the pure same wave with the normal broadcast with the characteristic complex envelope and pan with the illustrated figure 5 in light with the previous formula with the not so clear. Consequently, the person the formula should be viewed with the motor correctly the percentage power with the peak modulation minimum of the voltage rather than the peak voltage maximum. You would completely compensate with the percent of the modulation. The computed percentage shown with the percentage of the negative peak modulation. Negative peak modulation is equal to 1 times the unmodulated carrier voltage with the minus the voltage, meaning only the unmodulated carrier voltage. The radio frequency amplitude modulated with the complex waveform. So the preceding two modulation percent of the often differ, but you should define with the average percent of the modulation shown in figure 5.3. Average percent of the modulation is equal to 100 average voltage maximum minus the voltage minimum times 2 divided by 2 times the unmodulated voltage carrier. From the show the radio frequency amplitude percent modulation wave envelope voltage minimum voltage maximum unmodulated voltage carrier. From seeing the definition of the percent of the modulation you should know that the method of measuring all three types of the modulation percent of the measure must be divided by the differing value obtained, however they may couple necessarily directly related unequal positive and negative peak of the complex modulation wave. The possibility of distortion coupled with carrier shifting of the distortion may also produce the effect of the other modulation process. For example, the parasitic oscillation, nonlinear radio frequency amplification modulation, signal distortion present in the audio amplifiers. Unfortunately, continuous various percent of the modulation created by the number of the additional problems. For example, the dampen the condenser of the made can be provided average reading of the despite of the fluctuation. Average reading of the, on the other hand, with the not just scope of the present of the transient over modulation. Shortcoming with the shear that become of the large number of the sideband frequency produce the addition with the number of the one with the wherever the over modulation. Not only does their extreme frequency interfere drastically with the other transmission, but they also may significantly destroy the modulation with the categorization amount, the importance of the media with the response to the modulation. Specifically with the both positive and the peak with the negative peak over modulation must indicate the positive peak for modulation on the curve of the positive modulation exceeds the 100% of the negative peak, but the over modulation curve of the negative modulation exceeds 100%. Oscillator measurement and method. The oscillator with widely with the amplitude modulation mind with the measuring of the instrument, the sense of the capable of presenting visual indication of the modulated output of the AM transmit. The oscillator with the reliable detecting modulation, determine the percent of the modulation. For example, the relative of the error. Most measurement is taken in 5-inch CRT cathode. CRT with is about 10% of the accuracy of the main check with the oscillator. You would consider more valid with monitoring general modulation conditions. You would monitor the amplitude of the modulated output of the radio transmission photographic records. Type of the modulation display. The two type of the modulation pattern with involved provide with the oscillator depending on the hook. With the base pattern with the wave and low pattern with the shown figure 5.2, 5.3, and the trapezoidal pattern shown figure 5.4. No modulated X unmodulated carrier. 50% modulation. Negative peak. Negative peak, net positive peak, 90 to 95% modulation over to 100% of the modulation elongated by H1 more than two times to the antenna output, vertical to the ground, off the horizontal ground, transmitter modulator output. Figure 5.2 show the oscillator presentation of radio frequency carrier amplitude modulated by the complex wave that shifts the speak of the figure 5.4 and 5.4 and 5.5 show the effect of the over 100% of the modulation carrier of the wave the envelope of the pattern shown figure 5.3 obtained with applying the radio frequency modulated the vertical input of the oscillator with the trapezoidal pattern obtained with a similar manner except for the modulating signal with the transmit for the horizontal sweep of the oscillator instead of having the sweep of the signal generated internally by the oscillator. Both methods will limit the frequency response of the oscillator. Therefore, the method defined with the greater applicability of the low frequency and high frequency modulation. Low loss of the carrier frequency very high and ultra high frequencies. Measurement of very high and ultra high frequency modulation is normally measured with the applying on the specific level of clearance to determine the input to the modulator. This in turn produces a significant drop in the plate of the voltage final output of the state of the modulator. The current and setting of the output voltage ensure that overmodulation will not occur. Single sideband measurement. Single sideband modulation form of the amplitude modulation, which only one sideband with the trim is suppressed carrier with the sense of the band with balance modulators are used to provide the carrier cancellation, except when the balance of the carriers that provide cancellation require the null adjustment. The null can be observed adjusted either the detector indicator the strength of the voltmeter and oscillator with the observation output with the tuning of the transmitter. Measurement of particularly with the sideband technology include the special modulation amplitude with the modulation distortion. Check with the side modulator with the overdriven the missing with the oscillated associated linear amplified and properly loaded with the overdone with the spurious output frequency. They are produced that they are harmonically related to derivative signal that can cause the slider over the long range frequency that can cause interfering with the other transmission stations. To determine the proper amplitude of the modulation will account with the distortion displayed by the audio over the tone modulation. The resulting signal was shown figure A, B, and the C, with the figure 2.6 5.6 with the two tones have the initial adjustment of the pressure. Precise checking will be kept that will indicate the distortion. Two test tones corresponding with the wave and envelope of the amplitude modulation check. The two signal with the equal amplitude with a slightly different frequency of the beating together to apply with the sideband modulated produce a single tone with approximately 1,000 Hz on the oscillator. Output appear with a series of fully modulated with the same wave similar to 100% of the amplitude modulated wave shown figure A, view A, the spectrum analyzer representation shown in view B. Two-tone testing, observe the oscillator. Example of the ideal two-tone waveforms. Two-tone testing, observe the spectrum and analyzer. Two-tone testing, observe trapezoidal. When trapezoidal method 2 up over the triangle appears with the oscillator is shown with figure 5-6. View C, where there is equally a balance of the modulator with the triangle, the mirror image, elliptical straight line patterns equal appear with the phase distortion check is to be used. There's also the loss of the rough operating and drift the bearing audio drive with the microphone and the peak of the swings for the finite value final play with the tonic C with the check with the depend with the initial act for the calibration response with the character for the ammeter and the final state with the well as the other factors. Our frequency modulation with the carrier, the amplitude with the remain with the with the output frequency emitter vary with the carrier or mean over the frequency with the radius with the corresponding with the audio frequency extend with the frequency chain with the one direction with the unmodulated carrier with the frequency is called the frequency deviation. Deviation frequency is usually expressed with 1 kHz equal to the difference between the carrier frequency the other highest low frequency read for the carrier and excursion from the modulation. No modulation percent but is usually sensitive to the suitable circuit design frequency division that may be made with the largest desired encountering in any of the desired effects. Adverse effect equivalent over modulation amplitude modulation transmission however the maximum permissible frequency division is determined by the width of the band designed by the standing operation. Frequency modulation equivalent to 100% of the modulation of the wind, the frequency deviation equal to the predetermined maximum value of the treble. The method of measuring the modulation frequency modulation transmission. The frequency deviation measurement of the frequency modulation signal is normally performed with either a spectrum of the analyzer with the modulation analyzer with the modulation analyzer method is more commonly used because of the accuracy. The type of the accuracy modulation analyzers plus or minus 1% of the figure 5 show with the 5-7 show with the typical modulation analyzer 5-7 show with the typical modulation analyzer spectrum wave analyzer the measurement analyzer the complex waveforms perform and prepare to determine the graphical plot amplitude of the frequency done with the spectrum analyzer breaking down to the fact of the waveform composed of the summation of the group of the sinusoidal wave each of the frequencies all of the existing simultaneously. React with the degree amplitude time and frequency important with considering varying with the frequency of the time domain with the amplitude varies time plot with the considering phase relationship between the time of the signal normally observed with the end with the non-slopes frequency domain amplitude versus frequency plot with the absorbed the frequency response with the spectrum analyzer U for the purpose of the figure 5a illustrate the difference between the frequency and time domain plot with U8 illustrate the three-dimensional coordinate of the fundamental frequency of the second harmonic with respect to the frequency amplitude view B with the time domain display will be seen with the oscillator with the solid line with the frequency fundamental frequency time with the second harmonic with the actual display with the dash line fundamental frequency with the 2 time the second harmonic of the drum with the illustrate with the fundamental second harmonic frequency relationship with the formula with the composite of the fundamental frequency of the time the second harmonic plus the second harmonic view to see with the frequency display that will be shown will be seen with the spectrum analyzer note that the VC component of the composite signal that are clearly seen. View A 5-8 show the time versus frequency 5-8B show the time frequency fundamental frequency secondary harmonic frequency amplitude frequency time versus frequency. Our frequency domain display capability. The frequency domain contains the information not found with the time display spectrum analyzer can display with the component with more than one frequency like the signal and discriminate between the component with the signal measurement the power level of each one the more sensitive the low level of distortion and the oscillator sensitivity will have the dynamic range the useful with the measuring low level of modulation illustrating the view A and B with the figure 5-9 spectrum analyzer U with the measurement long in short term the stability with no sideband with the oscillator residual frequency modulation signal generated the frequency drift the device the warm up shown A and B and C with the figure 5-10. 5-9 show the example of the time domaining left with the frequency right domain on the left time. The distortion not visible oscillator display spectrum analyzer display modulation sidebands about 2% just visible and not measurement into the oscillator display spectrum analyzer display low level of modulation oscillator noise band spectrum analyzer stability measurements signal generated residual frequency modulation spectrum analyzer stability measurements. The swept frequency with the filter amplifier swept distortion measurement with the tune oscillator with the measure with the A with the spectrum analyzer with the help with the course with these measurement the variable present the display with the XY recorder that should be with the simply readable example of the tune oscillator harmonic with the filter respond with the illustrated in figure 11 the frequency conversion device and mixtures and a harmonic generator that usually characterized by parameters of conversion loss over the isolation distortion parameters are displayed within figure 512 with the A the spectrum analyzers. Show the distortion tune oscillator harmonic distortion, your swept distortion response characteristic, the desired output input feedback, feed through and distortion doubler, and input feed through the desired output distortion. Present day spectral analyzer can measure the segment of the frequency spectrum from 0 Hz to the height of 300 GHz with the waveguide mixture. Spectrum analyzer applications. Figure 513 show the typical spectrum analyzer of the previously mentioned branch with the capabilities can be used. Spectrum analyzer, however, you will find with the spectrum analyzer generally you the measure for the special spectral purity with the multiplex signal with the percentage of the modulation amplitude modulation signal, the modulation character with the frequency modulation, and the pulse modulated signal of the spectrum analyzer to interpret the displayed spectrum pulse with the frequency emitted with radar transmission. Complex waveforms are divided into two groups: the periodic wave and the non-periodic wave. The periodic waves contain the fundamental frequency related with the harmonics. Non-periodic waves contain the bands with the frequency, the result of the repetition of the period of the fundamental frequency approaching the infinite with the thereby creating the continuous frequency spectrum. Modulation and measurement of the L type of the modulation carry very proportional instantaneous variation. Modulation waveform 2 basic property the carrier variable modulation, the amplitude character of the angular characteristic, amplitude modulation, the amplitude modulation with contained entirely with the sidebands, amplitude modulation side will carry them in other sim wave will be displayed, and it is shown figure 514. For 100% of the modulation, total sideband power would be 1/2 of the carrier power. Therefore, each sideband would be 6 decibels to the left of the carrier, 1/4 of the power of the carrier is into the carrier component does not change and change with the amplitude modulation transmission. The total power with 100% modulated wave is 50% higher than the unmodulated carrier. The primary advantage of the log display with the provided with the spectrum analyzer over the linear display with the provided with the oscillator with the percent of the modulation measurement the high dynamic range of the spectrum analyzer up to 70 decibels allow with the accurate measurement of the value with those 6 hundredths of the percent, all allowed with the measurement of low distortion of the amplitude modulation signal with both capabilities illustrated in figure 515 view ABC charted in figure 516 provides the conversion of the decimal down with the carrier and percentage of the modulation amplitude with the carrier frequency and modulation frequency USB and LSB modulation 2% sidebands 40 decibels down, 28 decibels 12 decibels 50% modulation 12 decibels down, and 28 decibels down. 100% modulation sideband 4 decibels down, distortion 9 decibels down. Percent of the modulation and the decibels on the bottom. Note anything of the greater than negative 6 decibels exceed 100% of the modulation produced. Distortion shown in figure 516. In modern low range high frequency of the communication, most important form of the amplitude modulation, single sideband with the single sideband with the upper lower center of the sideband with the transmit with the carrier required with 1/6 of the output with the power of the amplitude modulation trim, the equal power of the intelligent power power less than half of the man with the figure 517 show the effect balance carrier of the amplitude modulation signal. Most common distortion experiment with the single sideband intermodulation distortion, which is coupled with the nonlinear mixing the intelligent signal with the two-tone test is used to determine if the intermodulated distortion exists. The figure 518 illustrates the spectrum analyzer display with the two test tone with the modulation applied with the upper sideband. Occur with a balance of 48.6 decibels. Suppressed carrier with 50 decibels down. Intermodulation production 50 decibels down. Frequency modulation, instantaneous frequency with the radio frequency waves vary from the modulation signal I mentioned with the Neets module 12. The amplitude with the keep that counts with the number of the time second per second. The instantaneous frequency vary with the average of the carrier frequency controlled by the frequency of the modulation signal. The amount of the frequency departed with the average of the control of the amplitude modulation signal. Variation of reference of the frequency deviation frequency modulation wave with the can now be just up with the two clear rules of the frequency deviation rate and with the amplitude frequency modulation. Amount of the frequency shift with the proportion with the amplitude of the modulation signal. This rule simply means that 10-volt signal called the frequency of the shift with the 20 kHz over the 20-volt signal with the we call the frequency shift with 40 kHz. The ratio of frequency should be proportional with the frequency of the modulation signal. The second rule means that if the carrier is modulated 1 kHz tone, the carrier is changing the frequency 1,000 times each. Check with the amplitude frequency of the signal you with the modulated with the carrier with determine both with the number of the significant sideband figure 519, amplitude with the sideband shown in figure 520 with the number of the significant sidebands band with it increase with the frequency of the modulation signal increases. Frequency modulation 90 kHz band with the spectrum carrier modulated with a 5 kHz signal with the 100 kHz band carrier modulated with a 10 kHz signal with the relative intensity of the spectrum over the frequencies spectrum of the modulation dex 2. Needs module 12 should be consulted in depth discussion frequency modulation principles. Pulse wave. Ideal pulse radar similarly is made with the up of the train with the radio frequency pulse with the constant repetition constant pulse within shape of the constant amplitude with the receive the energy and reflect with the target with the radar receive with the require with the ideal the pulse with the radar emission for the character of the observer the spectrum pulse with the radar signal easily with accurate measure for the character of the pulse with it and duty cycle. Peak average power with the principal radar with the cover the Neets module 18 radar principal consult with explain with the pulse wave. Rectangular pulse with the rectangular pulse with the pulse wave pulse modulate with the constant frequency with the radio frequency carrier with the produce the pulse radar output with rectangular wave made with the fundamental frequency with the combined odd and even harmonics. Figure 521 show the development the rectangular weave with the rectangular part in time and the pulse with the domain average value of the wave, the fundamental second harmonic rectangular pulse with the harmonic strum with the fundamental second harmonic average pulse with pulse wave and analyze the amplitude modulation sideband with the produce with the above with the below with the carrier frequency of the pulse is also produced above the low of the carrier frequency. The pulse is made with the main tone. These tones that produce the modulation band with the common referred to spectral lines or rails. The spectral analog with the display with the they're twice as many variables of the pulse module output with the radar of the harmonics contain the modulating pulse with the upper lower sideband shown figure 522 with the figure the pulse repetition frequency is equal to the pulse interval with 1 over the time of the actual spectrum of the analyzer display should be a lower lobe shown with the lobe of the reference line with the figure on the top of the cover of the spectrum analyzer does not retain the polarity information chain of the pulse interval over the pulse width of the modulation signal will change with the amount of the rails or pulse rate frequency and number of lobe minimum with the illustration figure 523. 522 show the pulse rate radar output and the figure 523 show the pulse rate chain with the cover of the unmodulating signal, pulse chain with the changing interval, chain with the rail density with the change of pulse with the width, with the chain with the number of lobes. Analyzer spectrum pattern. Leading and the trailing edge of the radar, radiated pulse modulating signal should have the sharper interval the rise time, the decay time, and the constant amplitude between them. The incorrect pulse shape of the the frequency spread of the polling of the result of the loss of the available energy of the frequency of the receiver, the tune, the primary reason for the analyzer of the spectrum, determine the exact amount of the amplitude frequency modulation, the amount of the amplitude modulation, determine the increase of the number of the sideband with applied with the pole spectrum. Increase the frequency modulation, increase the amplitude of the side bolt, low frequency, in either case the energy available to the main spectrum is decreased. Spectrum analyzer operation. Information inside with the spectrum at the beginning of the analyzer, determine the spectrum analyzer with the requirement of the real-time analyzer review with this map particular point with the frequency spectrum, the analyzer with the line spectrum of the display with the continuous sweep of the frequency, analyzer the most common mode of observation, with the display with the wide portion of the frequency spectrum, in most cases the entire range of the spectrum is the chain of the spectrum setting with one mode with another accounts with the varying sign of the scan with the bandwidth of the spectrum analyzer with the combination with the tube. Most of the real-time spectrum analyzers have the receive with the mechanical filters while limited with the input and the amendment of the spectrum analyzer with the spectrum to be analyzed. The turntable to swap with the spectrum analyzer with its functional basically the same with the heterodyne receiver. The difference between the local oscillator that is not to be used and replaced with the voltage controlled oscillator. The voltage controlled oscillator swept the electron only ramp with the solid tube that generated the output of the receiver with the coil into the cathode ray tube, which is horizontal sweep with the synchronizing of the voltage controlled oscillator low frequency players and the left over the cathode ray tube. The display trace sweep with the right over the oscillator with the increase of the frequency. Figure 524 show the block diagram heterodyne spectrum analyzer. Show the radio frequency signal into the crystal mix for the amplifier of the detector video amplifier to the cathode ray tube small tube generated the voltage controlled oscillator back to the crystal mixer. Because of the signal can be made with the spectrum analyzer that may be resolved with the resulting signal main with the distinguisher from the other signal near with the resolution limited with the narrow bandwidth of the spectrum analyzer. Because of the analyzer trace over the intermediate frequency bandwidth, its shape they also swept them through the signal with the nearest bandwidth of 1 kHz near to the 2 signal of the so a result of the 1 kHz producing interfrequency bandwidth indefinitely would be obtained with the infinite resolution except for the usable intermediate frequency bandwidth is limited with the stability of the spectrum analyzer. The smaller the intermediate frequency bandwidth, the greater the capability of the analyzer resolve the closely space signal with the unequal amplitude modern spectrum have been refined with the degree of the intermediate frequency bandwidth is less than 1 Hz. It is important that the spectrum analyzer be more stable than frequency with the signal the bench for the stability of the analyzer depend on the frequency stability of the voltage oscillator voltage control oscillator. Scan time spectrum analyzer must be long enough with respect with the amplitude signal to measure that it should allow the intermediate frequency circuitry spectrum analyzer to charge and recover that will prevent amplitude frequency distortion. Hard time domain reflectometry. The testing measure of the technique is incredibly useful in testing the transmission line, both metallic fiber optic cable, the strip line with the connect with the other broadband system, the component with the basically time delay with the reflectometer with the extent of the earlier technique with the reflect with the external pole with the locate with the fault with the determine the character of the power transmission line with the comparable time down with the reflectometer with the metry closed loop radar system with the transmitted signal with the flat and step pole with the fab with the into the system reflection result with the discontinuity and pin with the deviation system on a cathode ray tube. The technique of the time domain reflectometry is considered the feeding in pulp with the energy within the system and observe with the energy with the reflect within the system with the point of the insertion when the pulse pass right with the input with the pulse meets. This continue with the impediment of the mismatch of the resonant reflections of appearing of the feedback point are compared with the phase time and the amplitude of the original pulse by applying analyze the magnitude deviation shape of the reflected wave that you can determine the nature of the independent variation in transmission line sense of the distance of the related time and the amplitude of the reflected step of the directly related impediment of the comparison indicate the distance of fall as well as the nature of the fall. Figure 525 U, A, B, and C and D illustrate the typical transmission line problem can easily be identified by either the time domain reflectometer and the additional with showing the both the distance with the nature of the resistive and inductive capacitance each line discontinuity of the time the domain reflectometry. As a result, reveal the characteristic impedance of the line, indicate the wear is lost the shunt. There also be the locate of the analyzer connector and splices. Figure 525H of the time domain reflector ready display with the transmission display. The fried cable of the time domain display with the transmission line problems. Open the cable of the time domain reflector main display with the transmission line problems. And then you have your shorter cable of the time domain reflector display transmission line problems. Conventional method of evaluating high frequency transmission system with a component that have been made through the same wave ratio measurement that obtained with the overall indication transmission line performed with the method involved with the same wave of the signal of the system measuring the maximum and minimum amplitude of the same wave of the result of the system can discontinue the load mismatch of the ratio between the minimum and maximum standing wave ratio value within the state of the system figure of an error of the standing wave ratio measurement. However, it does not isolate the individual discontinue the mismatch where the multiple reflections are present and only indicate the total effect with the time domain reflectometry. On the other hand, isolate the line with the characteristic in time location as the result of the multiple reflection results from one or more discontinuity the impact of the variation that are separated with the distance of the line, separated the line and time minor point where they can be individually analyzed. Prior to the event of the time deflectum reflectometry of the time deflectum reflectometry performed with the aid of the sampling oscillate with the pulse regenerations for the various fast raised times. Figure 526 over the earlier type of the test set up, which is still with the observation. However, today the time the domain reflection is several in advantage for the old pulse regulated oscillate smash with the mountain time deflection reflectometer with the compact lightweight with other supply with a battery pack option field. You have to provide the direct readout with the distance instead of the time. Some of the equipment that provide with the paper timer recording the parameter permanent record with the figure 527 show the typical time domain reflectometer. Show the figure 526 with the time of the domain basic engineering setup generator field through the sampler oscillate 10-inch coaxial line system under test of the impedance load. Figure 527 the typical domain reflector swept frequency testing equipment. Our swept frequency testing equipment is used to determine the bandwidth, the alignment, the frequency response with impedance matching, actuation, various circuit with the system like with the swept frequency testing can be used to determine the broadband response with the device. Otherwise, we require the number of the separate measurement the manual applying responsive curve of the swept frequency. Techniques supplied with the electronic equipment, the spectrum of the volts, very low frequency or BL and EH frequencies, generally limited with only with the resourceful of the basic limitation equipment employed with the basic swept frequency arrangement. Figure 528. For the tracking generator interconnecting table, negative 30 decibels, 0 to 4, 50 megahertz input, millihertz or input output the device under the 0 to 50 millihertz, radio frequency input of the spectrum analyzer, 50 to 70 input of the matching adapter, shoot for the testing 75 the devices. The swept frequency technique can only be efficient with the determine the frequency response with an amplifier, with a filter, with the use of the analyzer, with the band, with the determination of the intermediate frequency radio frequency state of the test equipment, the permit with the direct visual readout with the cathode ray tube spectrum and analyzer. Spectrum analyzer can easily be connected with the X and Y chart record with the permanent record with the primitive desired figure 529 show the spectrum analyzer cathode ray tube display with the frequency response with the multi-couple of the track generator. You must be capable of sweeping the desired frequency range with the device under test. Show the typical spectrum frequency and response display reference for the test and megahertz. Tracking generator. The figure 530 show the typical tracking generator. You the Hewitt Packard 141 spectrum analyzer. The tracking generator is basically a sweep generator in which with the sweep rate with the match for the spectrum analyzer. The output circuitry of the tracking generator continue with the network that ensure the constant output amplitude with the entire range of the being swept with the failed frequency modulation signal produced with the track generator is applied with the device for the circuit under the test the instantaneous output amplitude with allow with the proportional response for the circuit of the frequency of the instant but the others for the original frequency modulator frequency modulation input the signal chain with the passing of the circuit under the tap of the output signal, therefore would consider the frequency modulation signal with the amplitude modulation for equal deviation of the positive and negative portions of the envelope are symmetrical because it is necessary to observe the only one side of the envelope of the detection side of the spectrum analyzer over the modulation remaining to appear favor the cathode ray tube. The presentation will appear with a continuous curve of the the persistent vision of the phosphorus character of the cathode ray tube. The polar of the detection term of the positive of the end, negative of the output of the display of the frequency and input of the cathode ray tube. The display can be analyzed with the resting scan spectrum analyzed with either electrically or manually with a point of interest for greater accuracy of the frequency determination frequency counter with the media attached for the output tracking the generated amount of the arrested scan. Impedance matching. The conventional turns cannot be conventional tuners cannot be successful to cancel the short load reflection of the swept frequency measurement the basic of the tuning effectively only single frequency, therefore the path of the isolator required. However, the automatic level to control the power output the sweep of the generator maintain relatively constant with the point of measurement. The sort of the impedance may thus they may maintain closely to the normal nominal value of the arrangement. Maybe the impedance variation connecting the cable connected to adapters effectively cancel the components that are within leveling loop actuation device of the test will display as associated with the cathode ray tube continues to respond with the curve of the scan. This will delay and the actuation varies frequently applied with the device for the under the test. Impedance circuit impedance of the measure for the conventional over the U of the reflectometer principle the image with an incident with the reflected signal single wave ratio with the transmission line feeding of the unknown and standing wave ratio and transmission line with the unknown and pen for the measure of the ratio between the signal to indicate with how closely loaded impedance match of the transmission line. Another method of the automechanical load with the control of the how the forward power at the constant level, the return load with the specific load with the measurement and short with the plate for the circuit with the 100% reflected power with the measure of the loss of the technically contained in the single standing wave ratio figures. Noise figure, the value of the frequency sweep of the receiver, the automatic noise figure, either you can make noise with the finger measurement with the broadband microwave device for the UV the travel the wave tube, and my amplifier with the conductor with the test properly. We must first check the received noise figure. Alright, sweeping antenna system testing one more common useful application for the sweeping technique the minimum parameter of the antenna system tested for the voltage standing wave ratio frequency the response of the impedance figure 531 show the typical test setup with the testing transmitting antenna voltage standing wave ratio to resemble the transmitting antenna that can also act the receiving antenna sending and induce the power the adjacent antennas back to the test equipment. You should make the initial power check on the antenna to prevent damage of the test equipment. Figure 532 show the typical high frequency transmission antenna voltage standing wave ratio displayed measuring by sweep frequency with the setup the testing with the receiving antenna voltage standing wave ratio. Figure 533 similarly exception over the actuator measure the same wave ratio within the operating frequency without any other broadband antenna should not exceed the voltage standing wave ratio of 2.5 to 1. Voltage standing wave ratio or single tune antenna should not exceed 1.5 to 1 tune frequency. Then show you voltage standing wave ratio test for the transmitting antenna, spectrum analyzer 20 decibels, reflected port, tracking generator, source port, directional port 50 ohms, 10 decibel watt antenna operator, legend incident wave, reflective wave antenna transmission line under wave, the typical spectrum analyzer visual source wave of the antenna. And legend incident wave reflective wave spectrum analyzer the track generator source port reflective port directional bridge 50 ohm load port antenna transmission line under test. And chapter 5 summary.